Okay.
The answer for the warm-up should have been 2. Answer on this one should be 11. The answer should be 1. The winning number is 1. Today's objective is a new one. Use complex numbers in polynomial identities and equations. Extend polynomial identities to the complex numbers. For example, rewrite x squared plus 4 as x plus 2i, x minus 2i, and that's what we're doing today. Now, before we go on to what we're doing today, you have to remember from Algebra 1 the difference of two squares, such as a squared minus b squared can be factored as a plus b, a minus b. You have to remember that, and we'll review it a little bit before we go on to the imaginary stuff. For example, just above that, if I had x squared minus 49, I could factor that as x plus 7, x minus 7. X squared and 49 are both perfect squares. You find the square root of each. Square root of x squared is x, and the square root of 49 is 7. You alternate the signs, and you factored it out. So over here, if I had x squared minus 36, I find the square root of each, x and 6, and then alternate the signs. If you solve it all the way through, you end up with an answer of -6 or 6 by just setting each equal to 0, if your equation is set equal to 0 to start with. What if we had x squared minus 64 equals 0? What's the square root of x squared? And the square root of 64? Alternate the signs. And then if you set each of them equal to 0, you can solve. So x in the first one is a -8, and in the second one it's a +8. So -8 or +8 would be the answer. If we had x squared minus 625 equals 0, x squared is a perfect square. Is 625 a perfect square? Yeah, so what's the square root of x squared? X. And square root of 625? 25. Alternate the signs. Answer should be 25 or -25. You could have x squared equals something like a +144, but if you move the 144 over to the left-hand side, it becomes a difference of two squares. However, if you would have left it like this, you could still do just the square root of both sides. The square root of x squared is x, and the square root of 144 is plus or minus 12. So there are your answers, -12, +12. Yeah, you could put plus or minus 12 for if it's -12, +12. And you can do that for the imaginary numbers coming up too. Now before you couldn't do the sum of two squares and factor them out like we do a difference of two squares. But today you can do a sum of two squares using imaginary numbers after you rewrite the equation just a little bit. So here's a refresher on imaginary numbers. We just went through them, but I want to make sure you still remember it. The square root of negative 9 equals what? 3i. Yes, as long as you remember that, you'll be good. But it's not just 3i, it's going to be, if you have a square root, then it should be plus or minus 3i. Square root of negative 16 would be what?
Plus or minus 4.
Well, for the ones that we're doing, it's going to be a perfect square to start out with. And then we're going to do some that are not perfect squares, where you have to simplify, like you break them apart. But we'll do this part first. What's the answer to this one?
Plus or minus 4.
Right, plus or minus 4i. What's the answer to this one?
Plus or minus 10.
Right. The square root of negative 1 times the square root of negative 1 is what?
I?
Not I.
I squared?
Not I squared. Getting close. Negative I squared is what?
I.
Not I. Not negative I. Negative 1. You don't have to go through all the I stuff if you remember that when you multiply two radical items together and the number is the same underneath each sign, the answer is just that number under the sign. Alright, so here's the first example of the sum of two squares. X squared plus 100 equals 0. Now, it's the sum of two squares, but you're going to have to rewrite it as the difference of two squares. And that's where the imaginary numbers are going to come in. What sign combination do we always change to plus? Minus a negative, right. So put x squared minus a negative 100. So now we have a difference, but it's technically not a perfect square because negative 100. But here's where the imaginary numbers come in. If I were going to break this apart as a difference of two squares, I have to find the square root of x squared, which is going to be what? X. So we put the x down there. And we know to alternate the signs. But now we're going to have the square root of a negative 100. Clearly we have to clean that up a little bit. So, just like we did those practice problems that I put up there that went by quickly, what's the square root of a negative 100? Plus or minus 10i, and you can just put 10i down when you're inside the brackets. We'll use the plus or minus when we get to the final answer. So it'd be x plus 10i, x minus 10i. And then when you get to the final answer, you're going to have plus or minus 10i. Here's example 2. X squared plus 121 equals 0. What do I need to do first?
Make it a minus negative.
Yeah, minus a negative. The square root of x squared is x squared, or not x squared, just x. Alternate the signs. But what's the square root of a negative 121? 11i. So the final answer would be plus or minus 11i. Give this a try. Drop it off up here. For the solution, you should have x plus 8i x minus 8i. So that makes the final answer plus or minus 8i. And don't forget you had to rewrite it as x squared minus a negative 64 equals 0 before you started.
Aren't you scared?
Well, we rewrite it to x squared minus a negative 196 equals 0. So break it up as x plus the square root of negative 196, x minus the square root of negative 196. And then we're going to have x plus 14i, x minus 14i. So the final answer is plus or minus 14i.
How did I get there?
A equals negative 1. So start with the x to the 2a power. That would make that x to the negative 2 power. And then across from that, the a power here is negative 1, so that's going to make this 1 over 2x. Now if we simplify the x to the negative second, that's 1 over x squared. Since these are equivalent, you're going to have 1 over x squared equals 1 over 2x. So what would x have to equal in that case? So whatever you put in here for x and square it, it must be equivalent to multiplying that number by 2 and getting the same thing. What number could I put in there? 2 is right. So the answer is J. You have to remember the midpoint formula, and the midpoint formula is going to be x1 plus x2 over 2, and that's for the x-coordinate of the midpoint. I don't have enough room to write the rest of it here, so I'll just put the comma there and do y1 plus y2 over 2. That gives you the midpoint. So if we did 3 plus 15 over 2 and then negative 6 plus 5 over 2, sometimes you don't even have to do the entire problem. This one is going to give you a negative half on the y value, which eliminates this choice, this one, and this one. So it should be A or E. If you finish this one out, 18 over 2 is 9. So the answer should have been A. There are two different ways to solve this. One is just do it in your head. The other one, there is a mathematical way to do it, and I'll give you a preview of that. Let me lower this down. And first, if you're just going to do it in your head, 2 to some power is 16. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. So that means 6x minus 8 must be equal to 4. So if you move the 8 over and add it, you get a 12. X would have to be 2. There is another way to solve it, and I'll give you a preview of this. You'll probably run into this in a little while. What you would do is the log of both sides. And I'm trying to fit it all in there. A property of logs says you can move that out to the left like this. Whoops, that should be an 8. There we go. And then you're left with log 2, and all that equal to log 16. If you divide both sides by log 2, you get log 16 over log 2. If you put log 16 into a calculator and then divide it by log 2, it comes back to be 4. And look at that. Same thing that we had over there. So it takes you right back to where you had it. This is what you would have to use, and we'll go through some of that this year. That's what you would have to use if you had something like 9 and then you had like a 4-digit number out there and you couldn't figure out what it was. This one you can do in your head. The way on the right you would have to use it if it was out of control, really large numbers. Things that are not squares. X squared plus 10 equals 0. Now that's clearly not a perfect square, but we're still going to follow the same steps. So we will have x squared minus a negative 10 equals 0. And we will still split it up like this when we factor with plus and minus. And you will have the square root of negative 10 under each of them. But now when you go to simplify, the square root of negative 10 should come out to be what? Not 10i. I square root of 10 is right. So your final answer would be plus or minus I square root of 10. Example 4. You have to rewrite this as x squared minus a negative 20 equals 0. And then when you factor it up, it's going to be x plus and x minus. You'll have the square root of negative 20 in each of them. And you'll still do the same thing that we did on the last step, which is you're going to have an I coming out of each one. But when you get to your final answer and you put plus or minus I square root of 20, you are not finished, because the square root of 20 can be simplified. So you would do plus or minus I square root of 4 square root of 5 to simplify it like we did before. And that would leave you with plus or minus 2i square root of 5. Square root of 4 is 2. And you don't put the I before the 2, you put it to the right. This is your final answer. What do I do first on this one? Yeah, make it minus a negative. What do I do next?
X plus and X minus.
And what do I fill in there? Square root of negative 32. Okay, now what?
Make it x plus I squared root of 32 and minus I squared root of 32.
Right.
So then we'll have plus or minus I squared root of 32.
Plus or minus I square root of 32. Now what?
Then you do plus or minus I squared root of 16 over 2.
Yeah, 16 is the highest perfect square that goes in. What's the final answer?
Plus or minus 4i squared root of 2.
Yeah. That's it.